Today's lesson is on the standard form. So far, we have looked at the vertex form of the quadratic relation. So when we're in the vertex form, we have y is equal to a bracket x minus h squared plus k. And the advantage of this form is that we're able to easily find the vertex. So we know that h and k is the vertex. Today we're going to start talking about the standard form. And the standard form is not something that we have talked about yet, but you have definitely seen this because when we were doing factoring trinomials, you've seen it in the form of y is equal to ax squared plus bx plus c. We're going to examine this form and see the advantages that we have for this. And then next, in the next couple lessons, we're going to talk about the factored form. Factored form, you have seen that before when we did factoring. Now, for us to get from form to form, it's kind of like water. Water exists in three different forms: water, ice, and vapor. This is the same. The quadratic relation is written in three different ways, and there's a purpose to each one, but we're able to convert it from one to the other using different methods that we know. So from vertex form into standard form, we would have to expand the brackets and then collect our like terms. If we were going from standard form to vertex form, we would have to factor. And if we were going from factored form back to standard form, we would also be expanding again. We're going to talk about going from standard form back to vertex form today and in the next class. And from factored form to vertex form, it's pretty complicated. So I would say usually it's easier just to go this way, even though there is a direct relation from those two. One more thing I'd like to mention is that the A that we see, you'll notice that there's an A in our vertex form, A in the standard form, and A in the factored form. The A term is the same in all the equations, meaning that when you look at the A term, you're always going to be able to tell the opening direction and the stretch or compression. Now, for us to go from standard form and to find the axis of symmetry that we need to create a table of values, we have an equation here. The equation is h is equal to negative b over 2a. And this gives us our axis of symmetry. But we remember that the axis of symmetry is also the x-coordinate of the vertex. So let's look at this in this context. We have y is equal to negative 2x plus 12 minus 11. Our a term is negative 2, b is 12, and the c term is negative 11. Let's substitute it into our equation. So h is equal to negative b, so that's 12, over 2 times a. So let's simplify negative 12 over negative 4, and we have h is equal to 3. Now, if I know that h is equal to 3, I'm going to say the axis of symmetry, x is equal to 3. The next question we have is find the vertex of the following quadratic relation. If I know the axis of symmetry, I already know the x-coordinate of the vertex. And for me to find the y-coordinate, I would just have to substitute it back in to find the corresponding y. Let's do the same thing. We're going to start by finding the axis of symmetry. So I'm going to identify a is equal to half, b is equal to 1, and c is equal to negative 4. So my axis of symmetry, h is equal to negative b over 2 times a. Let's simplify. H is equal to negative 1 over 1, and that simplifies to negative 1. So if negative 1 is the h, or the x-coordinate of the vertex, for me to find the y, I'm going to substitute x is equal to negative 1 into the original equation. So we have y is equal to half times negative 1 squared plus negative 1 minus 4. Y is equal to 1 over 2 minus 1 minus 4. Y is equal to negative 4.5. So negative 4.5, or as a fraction, I have negative 9 over 2. So our conclusion, the vertex is negative 1 and negative 4.5. So if we're graphing from the standard form, the main thing that we need when we're graphing is to have the axis of symmetry so that I can find the vertex. Let's use this equation to help us find the vertex so that we can graph. The equation y is equal to negative half x plus 6x minus 1. I'm going to substitute in my h. H is equal to negative 6 over 2 times negative 1. The h value is 3. So I'm going to place my 3 here, knowing that this is my vertex. Let's substitute my value, negative bracket 3 squared plus 6 times 3 minus 1. So a vertex, 3 and 8. 1, 2, 3, 8. All right, I'm going to place values around it. And I'll do one side so that I can substitute it in for the rest. Negative 2 squared plus 6 times 2 minus 1. That's a 7. So the mirror image would be here. Negative 1 squared plus 6 times 1 minus 1. 4. And finally, 0. Negative 0 squared plus 6 times 0 minus 1. Negative 1. I'll fill in the rest. 7, 4. Oops. Let's join the dots. And we have our parabola. Y is equal to negative x squared plus 6x minus 1. Let's do one more example of this. When we have a graph like this, we must first find the axis of symmetry. The axis of symmetry, we use the equation h is equal to negative b over 2 times a. We have negative 2. I'm going to place some numbers around it. Negative 2 is our vertex. So 2 times negative 2 squared plus 8 times negative 2 plus 5, negative 3. Negative 2, negative 3. Let's substitute our next one in. Negative 1. And on the mirror side, we're going to have the same. Negative 4, positive 5. So on the mirror, we will have the same. And finally, negative 5. Positive 15. Now we know that that goes really high up, so it's going to be a very steep line. I'm just going to draw arrows to show that it continues up that way. So this is a fairly rough graph, but we have y is equal to 2x squared plus 8x plus 5. Now one more thing. Let's talk about the y-intercept. I want you to go back to the previous 2 pages and examine the y-intercept and the c of the equation. Do you notice any similarities? Okay, so let's go back this slide. Our y-intercept happens at 0, 5. The equation y is equal to 2x squared plus 8x plus 5. Okay, the first graph that we drew, y-intercept 0 and negative 1. The equation y is equal to negative x squared plus 6x minus 1. Now you're probably going to say to me, yeah, I did notice some similarities. You've noticed that the similarity is that the c value is the y-intercept. So why is that? It's not a coincidence. It's because we know that for all y-intercepts, we have x is equal to 0. So let's substitute x is equal to 0 in these equations. Y is equal to 0 squared minus 6 times 0 plus 5. Y is equal to 0 minus 0 plus 5, and y is equal to 5. So the y-intercept is 0, positive 5. It follows that the y-intercept is always going to be the c term because whenever we substitute 0 into a term that has an x, it's going to become 0. So looking at this equation, I can say that the y-intercept is always going to be whatever doesn't have an x squared term or an x. This one is a bit tricky. I have negative 2x squared plus 12 minus 16. These two are like terms. We're going to have to combine them together. So let me simplify the equation before I substitute it in. We have negative 2x squared minus 4. This is now the c term, and we know that this term will become 0 once I substitute x is equal to 0. So our y-intercept, 0, negative 4. Right, so the summary for graphing in standard form. How do you graph a quadratic relation in standard form? We need to first find the axis of symmetry. And the axis of symmetry, h is equal to negative b over 2a. Once we find the axis of symmetry, we're going to use this as the middle term in the table of values. And then you're going to continue with the table of values. Second key idea from this lesson, what do we know about the standard form and the y-intercept? Well, we've concluded that the y-intercept is always going to be 0 and c. C being the third term of the standard form. Because when we substitute x is equal to 0, the other two terms become 0, and the only value that remains is the constant.